Hello and welcome to this Python tutorial. Today we're going to implement support vector machine, or most commonly called SVM, on Python. So let's start right now. We're going to go to File, Explorer to set our folder as working directory. So we go to Classification, then Support Vector Machine, and here's the folder. Make sure that you have the social network add CSV file, and you can click on this button here to set the folder as working directory. So let's start now. We're going to use our classification template to be efficient and get all our code almost ready, because we will only have a few things to change. So here I'm pasting all the template, and now we need to change a few things, very few things. We need to create the classifier here, which will be the SVM classifier, and then below we will need to change just the titles of the graphs. So here we're going to replace classifier by SVM, and same here, classifier by SVM. And now what we only need to do is to create our classifier. So here I'm going to replace SVM as well. Right. Okay, so same as usual, we're going to import a class from a library, and then we're going to create an object of this class, and then we will use the fit method of the class to fit the classifier to our training set. So let's do this. The class we have to import is svc, and we are going to import it from scikit-learn.svm. So here we type from sklearn.svm, here it is, import svc. All right, so that's the class, and now let's create an object of this class. So we're gonna call this object classifier as usual. So let's do this, classifier equals, and then we're gonna call the class svc, and now we're gonna input the parameters. So let's inspect the svc class and let's see what the parameters are. So command or control plus I to inspect. And here are the info about svc and the parameters. Okay, so the first parameter is c, so that's a penalty parameter, which we won't need right now because it's to improve the model if we need it, and that we will see at the end of this part. However, there is this important parameter here, which is the kernel, and since we're starting with the basic SVM, with a linear kernel, here we're going to specify that we want the linear kernel, because as you can see, the default value for kernel here is RBF, which is the Gaussian kernel. You can see that there are several kernels, like the linear kernel, the polynomial kernel, the RBF kernel, which is the Gaussian kernel, sigmoid kernel. Well, there are a lot of kernels to try. I invite you to test them all. You're gonna have some interesting results. But let's start with the basics. Let's start with the most simple kernel, which is the linear kernel. And as you can guess, this will make our classifier a linear classifier that will look like the logistic classifier. So here, let's input the first parameter, which is then kernel. And let's set it equal to linear. All right. And now, what is the second parameter? Okay, so the degree here is in case you chose a polynomial kernel, then you can choose the degree of your polynomial kernel. So here, we're not concerned with that. Then gamma is another parameter in case we chose an RBF poly or sigmoid kernel. So we don't care about this one either. And then we have some other parameters that we won't include in our classifier. Actually, we will only include this random state parameter, which is the last one, in order to all get the same results. Well, you're welcome to choose another random state or not to include a random state, but it's just, if you want to have the same results as mine so that you can follow more easily what I'm describing on the graphs, on the following graphs that we're going to plot. So here we're just gonna add random state, and we will set it to 0. And that's it. The classifier is ready. And now let's fit it to the training set. So as usual, very simple. Classifier dot fit. So here I'm taking the fit method, and then we will fit our classifier to the training set, that is xtrain and ytrain. And it should be ready. So now let's execute the code. So we're going to first execute this part, which is the data preprocessing part. So let's do this. Here we go. Now the data is all well preprocessed. Perfect. And now we can execute this part, which is the fitting of the SVM to our training set. So let's do this. Ready, execute. Perfect, everything looks great. So here we have all the default parameters that were selected because we didn't specify them. So that's all good. We can have a look at our variables in Variable Explorer. Here we have our data set, the training set, and everything looks great. Okay, and then now that our classifier is ready and fitted to the training set, we can predict some new observations. And these new observations are, as usual, the test set observations. So here we can execute this to get the vector of predictions. Here it is. Now let's have a look. Ypred, and let's also open ytest. All right, so here is ytest, here is ypred. So these are the true results. These are the results that really happened. Did the users really buy the SUV, yes or no? And here, the predictions. Did our model predict that the users buy, yes or no, the SUV? So let's see, it looks good. From this, it looks like there's only good predictions. Let's have a look. So the first 6 users didn't buy the SUV, and our model predicted well that they didn't buy the SUV, so that's great. 7th user, yes. Yes, here as well, perfect. Now let's look at the first mistake. Let's see. Okay, so I'm jumping down. Wow, everything looks great. That's kind of unusual. Let's see. Okay. Wow, what's wrong here? What's happening? Ah, and here is the first incorrect predictions. I find that a little weird because I thought that this was the first model that was 100% right, which is very rare. I mean, you will never have a model that is 100% right. And by the way, there is this saying that says all models are wrong, but some are useful. So here's our first incorrect prediction to prove this. So yes, there's this mistake here, incorrect prediction for the 31st user of the test set. So this 31st user bought the SUV in reality, and our model predicted that this guy wouldn't buy the SUV. So that's the first incorrect prediction. Okay, so let's press OK, OK. And now let's have a better look at the incorrect predictions in one shot by looking at the confusion matrix. So from what we saw comparing Ypred and Ytest, this looks really great. So I'm curious to see how many incorrect predictions we have. So let's select this part about making the confusion matrix and execute. And now let's see, confusion matrix right here. Oh, okay, so I guess it was just a coincidence that all the first observations had good predictions, because we still have 10 incorrect predictions. 8 plus 2, here are the incorrect predictions. But that's not too bad. 10 incorrect predictions on 100 observations is not that bad. So yes, like 10%, it's okay. Besides, it's on new observations. It's not on the training set where the model was built. So okay, and now time for fun, time for the best part. We're going to visualize the training set results. So now we would like you to think and try to predict what is going to happen on the graph. We already know that we chose a linear kernel, which suggests that our SVM classifier is a linear classifier. So try to picture, try to guess in advance what the prediction regions are going to be and what the prediction boundary is going to be. And then let's execute the code. Okay, so you can pause the video. I'm going to execute the code right now. So first I'm starting with the training set results. The title was replaced. Everything looks good. We are ready to plot the results. So let's do this. Command or Control plus Enter to execute. And here we go. SVM. I'm going to enlarge this. All right, so that's our training set results for the SVM. So did you guess in advance that we would obtain a straight line here? Well, of course, that's because we chose a linear kernel, so the SVM is then a linear classifier, and as explained in the logistic regression section, a linear classifier in a 2D dimensional space is a straight line. And as the data is not linearly separable, it's making some incorrect predictions here because those green points here are users that are aged a little over the average and have a salary a little below the average, but don't fall into these same category as these guys who didn't buy the SUV, they actually bought the SUV. But since the SVM is a linear classifier, then it's a straight line, and therefore it couldn't make a curve to, contour all the red data points this way so that these green points would fall in the green regions. So that's the incorrect predictions, and same as here we have some incorrect predictions. As you can see, these are the green points, so the users who really bought the SUV were predicted not to buy the SUV because they are in the red region. Alright, so interesting, but actually it's kind of the same thing as logistic regression. So, we started with logistic regression, we improved the model with KNN, K nearest neighbors, and now we kind of went back to the lower level, but don't worry, next time we will build a more sophisticated SVM because we're going to choose a different kernel, which is going to be a Gaussian kernel, so this will make our SVM non-linear classifier, and you will see how it will make a terrific job. So actually you can try to do that yourself. It's quite simple. You just need to take the SVM code again and try to play with the new kernels. Well, you can actually try the Gaussian kernel, RBF, or the polynomial kernel, or even the sigmoid one for fun. But if you choose a linear kernel for SVM, you will get this result. And so it's going to be the same for the test set results. If we look at them, we're going to also obtain a straight line. Well, because actually this won't change because this is the prediction boundary built on the training set, so this won't change, but our test set results are actually going to be the same if I enlarge this. Alright, as you can see, it's placing most of the red users that are the users who didn't buy the SUV in the right prediction region and the green ones in the right green prediction region, but it's still making some incorrect predictions here because we have those same guys who are a little older and a salary below the average who still bought the SUV because the SUV is really cool and cheap. So yeah, that's the same result as logistic regression. So I look forward to showing you what kernel SVM can do because this will make a terrific job. Because it will even be better than KNN if we are concerned with aesthetic. Because as you remember, the KNN had a lot of irregularities. Here we're going to obtain a beautiful curve that will classify well all the data points. Well, not all the data points, but most of them, and especially these guys here, who won't be incorrect predictions. So I look forward to seeing you in the next section about kernel SVM after we complete SVM on R. And until then,